In this lecture, we're going to continue our investigation of the research process by focusing on a very important element, which is the hypothesis. And generally, when we think about the hypothesis, we're essentially making an educated guess. And as it applies to a research study, we're basically answering the question as to what we think might actually happen. Now, this is going to be based upon previous research, theories, and analytical approaches to a problem, but oftentimes, particularly in very new areas of research, sometimes it truly is an educated guess as to the outcome might not be clearly forecasted. And so there are two different hypotheses that we'll address. The first is what's called the research hypothesis, and this is based upon knowledge of a particular area. It's based upon previous research. It's based upon any theorems that might factor into what researchers might forecast could be the outcome of an experiment. And then there's what's called a statistical hypothesis, which is not an educated guess, but the statistical hypothesis, as the term might suggest here, is one that is statistical in nature, in that it evaluates the outcome of a quantitative experiment, so experiments that use numerical values to describe outcomes. And this approach evaluates the probability of an occurrence. And there are two unique statistical hypotheses made in every quantitative approach that are using statistical inferences. And that's the null hypothesis and the alternative hypothesis. And both of these hypotheses are stated in order to evaluate what's called type 1 and type 2 error probability. And this relates to the theory that large volumes of data distribute in a normal manner. And the question here from a statistical perspective, which is beyond this lecture, is evaluating how close the outcome of an experiment aligns with that theoretical normal distribution of a larger population. To understand and develop a hypothesis, oftentimes scientific laws forms the basis of the hypothesis, which is a statement that's based largely on repeated experimental observations, and that leads to conclusive observations. One such example includes Newton's laws of motion. This is quite a bit different than what's called a scientific theory. And so a scientific theory could be plausible, but doesn't have the same foundation as a scientific law. So for example, psychology relies more on theories than on laws. But a scientific theory is very well substantiated explanation of an event and is based upon a great deal of research and other forms of information. So, to understand the key concepts in the hypothesis, it's important to understand a couple of items here. The first is a variable, and in a research study, a variable is that element that can assume different values, and these variables can be qualitative or can be quantitative in nature. A constant in a research study that is actually an important concept when generating and developing the hypothesis. It's referring to a factor in the study that does not change. So from an experimental perspective, in order to base conclusions on the outcome of an experiment, oftentimes those experiments must incorporate a control situation or a control condition. And the whole point of that is that the experimental control that is incorporated into a research study functions to eliminate confounding items. So other elements that could affect the outcome of the study that would basically contaminate a study that we don't want in there. And so experimentally, there are ways to incorporate that control in order to arrive at valid conclusions. And so how can these concepts be defined? There's what's called a conceptual definition. And when we think about a conceptual definition, it refers to the general definition of a variable. That's different from an operational definition. So when you think about a conceptual definition, this is a definition that is used in everyday life. An operational definition is defining that concept in a very specific way for one and only one research study. So it puts the conceptual definition in context of the research question. For example, a conceptual definition of personality is that personality refers to the characteristic thoughts, emotional responses, and behaviors that are relatively stable in an individual over time across circumstances. And so we can see this conceptual definition that is applicable to a wide range of different situations. However, to carry out a research study, the conceptual definition provides the foundation, but is not sufficient in order to carry out that research study. So the research study, which is based upon evaluating personality, must take the concept and operationalize it in a very specific way. And so a more specific view of personality is what's called the Big Five. And that refers to 5 unique traits of personality, which include openness, conscientiousness, extroversion, agreeableness, and neuroticism. And so each of these 5 elements, referred to as the Big Five, can be measured on a scale and generating a quantifiable value that along a spectrum. So now we have that very general concept, but now what we've done for a particular research study is that we've operationalized the definition in a way that we can measure it qualitatively or quantitatively, and that's going to be specific to a research question. It should be noted that the operational definition is one that should also be generally acceptable to a particular field of study and is a natural extension of the conceptual definition. There are different types of hypotheses we'll address here on this slide. So the first one here is called a deductive hypothesis. And a deductive hypothesis, stemming back to an earlier lecture, is that with deductive reasoning, we deduce from theory to get a specific and arrive at a very specific outcome. And so the deductive hypothesis is based on just that. It's based on a theoretical foundation with minimal direct observation. So based upon the theory, we would arrive at a very specific conclusion. The opposite direction is the inductive hypothesis, which is based primarily on experimental findings. And so this is represented in examining patterns that are displayed in research papers, public health data, and so we have these direct observations from people and experiments, and we take those direct observations and we induce to a general conclusion, a general wide applicable conclusion. Now, the research hypothesis states, as indicated earlier, that educated guess what the researcher will think will happen. And so what the researcher thinks will happen is that some variables will be different from each other, or different variables will be related to each other. Or the researcher may hypothesize that two variables of interest may not be different from each other, or there may be no relationship between two variables. And sometimes that is the same. So sometimes the outcome or the research hypothesis is the same as the null hypothesis. And so once again here, this very bottom of the slide that highlights the null hypothesis. The null hypothesis is a statistical hypothesis that will always state that there's no difference despite the researcher's research hypothesis. On this slide here, this is an excerpt from a research paper, and this research paper published in 2011 examined what's called RPE, or ratings of perceived exertion, and muscle strength between young adults and older adults. And in this research paper, the final paragraph, this is an excerpt, a copy and paste of the final paragraph of the introductory section of the paper prior to the paper getting into the methods section. And so in a research paper, the last part of the introduction is used for the authors to state the objectives of the research study and any hypotheses that may exist. And so we see here in the first sentence, very long sentence, but we use commas and colons here to separate it. We have the objectives of the study are clearly stipulated here in the introductory section. The same paragraph will now get into what are the hypotheses that the researchers developed, or in this case, the one researcher developed as to what the outcome of the study is. Now, in this paper, note that there were 1, 2, 3 different hypotheses made by the researchers. And what's notable here, and this is always a very strong suggestion, is that when stating a research hypothesis, that there's some citation that provides a foundation as to why the researchers think this is going to happen. So if we look at the first hypothesis, it was hypothesized that healthy older adults will underestimate their perceived exertion, the subjective feeling they experience when they're performing muscle contractions, across progressively greater contraction intensities. Now, based upon this guess here, this educated guess, there's a research study in the reference section, number 7, a previous study that led the researchers to suspect that this is what might happen as part of the experiment. And so we have the first research hypothesis has actually 2 citations, the second has 2 citations, and the third hypothesis has 4 citations. So it always adds considerable strength to a research paper or to a research proposal. If the research hypotheses are well sourced, well referenced, it doesn't mean those previous studies have to actually carry out the exact same experiment, but if there's a foundation that led the researchers to suspect something, that's the way to do it, is to provide those resources and those citations. Just a couple of more elements here. Some final thoughts here on the research hypothesis is that researchers should ask themselves these questions. Does their educated guess correspond with reality? Does it make sense when they step back and not focus so much on the numerical values, but is it consistent with past research? Is it foundational? So even if the researchers believe that their hypothesis breaks with traditional thinking, is there a foundation for that based upon theory and or previous research outcomes? Is the hypothesis parsimonious, which refers to phenomena that behave in the most economical or efficient sort of way. And that there's a concept called Occam's razor, where making a minimum number of assumptions or the easiest or the simplest, not the easiest, but the simplest solution to a problem is usually the correct one. That's what Occam's razor hypothesizes here. So, is the reasoning behind the hypothesis so complicated and convoluted that it's very challenging to articulate or to work through into something testable? Or is there something a little bit more simple that might account for why the researchers are thinking that this might be the outcome of their study? And so another element of the hypothesis is how specific is it? And there's a concept called the Barnum effect, and that refers to the tendency of people to believe general descriptions of their own personality are highly accurate. And so is that in thinking about the Barnum effect, when researchers put together their hypothesis, is it falsifiable or is it refutable? And so in actually conducting a research study, when we think about just taking things at face value, which is really what the Barnum effect is really going towards, that people will generally believe those general descriptions are highly accurate. When we talk about conducting research, we're questioning whether those descriptions and assumptions are in fact accurate. And so that is often something that researchers should try to challenge in terms of an assumption. So research studies must be able to accept or refute the hypothesis put forward by the researchers. So this ends this part of our research process unit on the hypothesis.